Hi everyone, welcome back to Geeks. In this video, we will discuss the problem minimum cost of ropes. So let's read the problem statement and see what the problem says. Problem says that there are n ropes of different length that are given to us. Now we need to do what? We need to calculate these, we need to connect these ropes into one rope. So basically a lot of ropes have been given. In general, you can say that n ropes have been given to us with different lengths. Okay, and what we need to do is we need to connect them into one single rope. Now whenever you connect two ropes, so there is a cost for it. Okay, and ultimately you have to tell that what is the minimum cost in order to collect in order to connect all the ropes into one single rope finally. So what do we mean is in this case, let's say there is a rope 3 and there is another rope, let's say 5. Okay, and there is another rope, let's say 4. So these are the three ropes that we have. One rope is of 3 length, another is of 5, another is of 4. Now assume that if you are connecting the rope 3 and 5, let's assume this. If you are connecting the rope 3 and 5, okay, then for this particular connection, like after connecting this, the new rope will be what? The new rope will be having the length as 8. Correct. The new rope will be having what? The new rope will be having the length as 8. Now once the new rope has the length as 8, so you will be paying the cost of 8 also for this particular process of connection. Now after that, you will get what? You will get 8 and 4, because 5 and 3 are connected, then you will get 8 and 4. Now once you get 8 and 4, then what will happen? Now you have to connect these two ropes. So when you will connect these two ropes also, so now the new rope will be 12, and for connecting these two ropes, the cost will be the same as the length of the new rope. Okay, because if you connected 3 and 5, you got the new rope as 8, so that is the cost. Then if you connected 8 and 4, you got the new rope as 12, so that is the cost for this step. So like you will pay the cost as 12. So you can see here that if you will see the total cost in this way, you'll get 20. Now is it the most optimal answer for this particular test case? No, because if you will see, we are getting 20. But if we would have connected the rope in a different way, let's assume that if I had 3, 5 and 4, okay, I want to minimize my overall cost. Okay, if I want to minimize my overall cost, what should I do? I should minimize the cost of connecting the ropes at every step, because if I minimize my cost at every step, cost of connection at every step, then finally my cost would be minimum. Okay, so whenever we are connecting the ropes, we would try to connect the two two of the smallest possible ropes at that point of time, so that the cost is minimized. So if I'll try to connect here, what will happen is I'll connect 3 with 4. Okay, when I connect the ropes 3 and 4, because these are the two smaller ropes. Okay, so because at every step, if I'll try to minimize my cost, then only I'll be able to ultimately minimize the overall cost of the connection of all the n ropes. So 3 plus 4 is what? 3 plus 4 would be 7. So now the new rope will be having the length as 7. Okay, and other rope is already 5. So far the cost has been what? So far the cost has been 7. Then after that, you will add these two also, so you'll get what? You'll get 12. Then the cost for this connection would be 12, and you can see that now my cost is how much? Now my cost is basically 19. If my cost is 19, this is much lesser compared to what compared to what we got, because we got 20. Right now we are getting 19, so this connection is giving us lesser cost. So the way that we connected was, we always connected the two least uh, ropes, okay, at that point of time. So if you have to do what, if you have to minimize the cost of your overall connection, you should minimize the cost of connection at each and every step. So you should take the two smallest ropes at that point of time. Now let's take another example. Suppose that if you have got what, now you might think that we have to sort the array and we have to connect the two smaller ropes. No, that will not be the case, because if you will see here, let's say what we have is, suppose we have got something like 3, then we have got 4, okay, then we have got 5, then we have got 6. If we have got this particular test case here, now in this case, what would happen? Now when I connect these two ropes, suppose that if I connect the smaller ropes, right, so initially 3 and 5 are the smallest ropes, so I'll connect both of them. Now if I connect these two, then what will happen? Then you'll get 7, 5 and 6. Okay, so like your cost at this step would be 7. Now you would not connect 7 and 5, right? Because 7 plus 5 would give you a higher cost. If you want to connect two ropes at a point of time at this stage, you would connect 5 and 6, because connecting 5 and 6 will give you lesser cost here. I hope you get my point. So this is one thing that's very important, right? So you will connect what? You will connect these two. So you can see that now the array is not sorted, right? Because you're connecting 5 and 6. So that is why what we need to do is, we need to have a data structure which can always give us the minimum elements in a very quick time. So which data structure comes to our mind? basically there is a data structure that is known as min heap. Okay, so we need to use the min heap data structure because min heap will help us to do what? It helps us to get the minimum element in log of n time. Okay, we can always get the minimum element in log of n time, and we will get the two minimum elements very quickly at every step. Okay, then we'll be able to connect them. So by doing this, what will happen when we make one connection, that would take order of log n time. Okay, and overall how many ropes we will be connecting? If you connect, if you keep on connecting one by one, total number of connections that will be needed is n minus 1, because if you connect n minus 1 ropes, then overall every rope is connected, right? So this, the cost will be n minus 1 log n. So you can say that it will be overall n log n only, right? So this is one thing that's very important, that priority queue will help us to get the minimum elements in log of n time. For one connection we would take log of n time, so overall we will take n log n time, because heapify process in the max heap, in the min heap or max heap takes log n time. So overall complexity would become n log n. Obviously we are having space complexity of order of n here because we'll be using a min heap, but this would eventually solve the question in lesser time complexity. Okay, so let's see the test case and then we'll try to better predict. So suppose that we have got 4 to 7 6 9. Okay, suppose that we have got what? We have got 4 to 7 6 9. If we have got 4, then 2, then 7, then 6 and 9. Now we will declare a min heap here. So we have a min heap here. Okay, we have got what? We have got 4, then we have got 2, then we have got 7, then we have got 6, then we have got 9. Now you take the two minimum elements out. Okay, so what are the two minimum elements? You have got 4 and you have got 2. Okay, these are the two minimum elements. So take them out and connect them. What will be the cost for this connection? The cost would be basically 6 here. Okay, and now you will have a new rope as 6. Now when you take the two minimums out now, so they will be 6 and 6, so you take them out. Now the new rope would be 12 and the cost that you will pay is 12 also. Okay, so this is what you will pay. Now after that, the two minimum ropes are 7 and 9, so take them up. So you'll get what? You'll pay the cost as 16, and the ropes are basically, the new rope is of length 16, the ropes inside are 12 and 6. Now when you take the sum of these two, what do we get? When you take the sum of these two ropes, 12 and 16, you will get basically 8 and then 2 here, 28. Okay, now only one rope will be there because you will take these two out after connecting them, right? So there will be only one rope, and if there is only one rope, if the priority queue size is not greater than 1, so there is only one rope, this means that we have connected the rope overall. Okay, only one single rope is there after connecting everything. So we have got 6 plus 12 plus 16 plus 28. So we have got what? 6 plus 28 plus 28. Okay, if you add this up, this would be how much? This would be basically 6 plus you can say 56, which is going to be 62. Let's check if our answer is 62 or not. I hope it should be 62, and you can see that expected answer is also 62. So if you want to minimize the overall cost, you have to think greedily and you have to minimize the cost of connection of two ropes at every step. And the data structure that I need for that is minimum min heap or priority queue, because I want the two of the smallest rope at every step, at every connection, whenever I want to connect the ropes. Okay, so let's try and code this up so that we can submit this problem also, right? So what I'll do here is I'll declare a long answer variable. Okay, why we are taking long? Because if you connect, so the cost will be beyond integers, right? And also the lengths are given in long. Okay, then after that, what we need to do is we need to declare a priority queue or a min heap. So we'll declare a priority queue of long, comma what, vector, then long, okay, comma greater long. Okay, so we have declared a priority queue here, that is min heap. Initially we'll insert all the ropes inside. So we'll say we'll iterate from I starts from 0, I is less than arr dot size. Okay, then we'll do what? We'll do I plus plus. After that, what we are going to do is we are going to push the ith element inside the priority queue, and once we are done with that, then the next process will be that we will iterate till the priority queue size is greater or equal to 2, because if there are two or more than two ropes, then you need to keep on connecting by taking out the two of the minimums. Okay, so long a will be what? It will be pq dot top. So take the top element out and then pop it out. Okay, then after that, long b is equal to what? pq dot top again. So the next minimum element is what you take out, next minimum rope. Okay, and then remove it also. Then after that, what you do is in the answer variable, you will update the cost as what? A plus b, because you're connecting these two ropes. And in the priority queue also, you need to push a plus b, because the new rope length will be a plus b. and then after that you simply return the answer. Okay, so this is something that we'll do here. Let's try and compile this code to check if it is working fine on the sample test cases or not. It should, and the output is fine. Okay, let's try and submit this to check if it is getting accepted or not. Okay, so let's see. Yeah, so the code is getting accepted on all the test cases, right? So basically the code is correct, that is why it is getting accepted. I hope that you have understood this problem. Maybe there was some issue with the compile button because the output was showing as -1. Yeah, so I hope you have understood this question clearly. In case if you have any doubts, you can mention that in the comments. Also, talking about the time complexity of our code and space, time complexity, as I told you, will be order of n log n, because for one time the heapify process takes log n time. So overall n ropes are there, so that would be n log n. Space complexity will be order of n because we are taking priority queue or the min heap data structure for solving our problem. Okay, so I hope you have understood this problem clearly. Make sure to submit the code also, and if you have any doubts you can mention in the comments. Thank you for watching this video, guys.